Good afternoon, everyone. Thank you for joining us today for our webinar, which we have titled as Unlock Efficiency in Sourcing, Leveraging Artificial Intelligence with PartSupply Enterprise. So today webinar will be delivered by technical experts from EDS Technologies as well as Dassault Systems. So the flow of the webinar will be first small introduction of our company EDS Technologies will be done by Mr. Sri Kumar Maganti, Senior General Manager Technical, and then post that we'll introduce our technical speakers for today from Dassault Systems, Mr. Ratish and Mr. Uma Shankar, and then we'll hand over to them for the technical presentation. So over to you, Sri Kumar sir.
Thank you, Abhay. We'll be starting this webinar on unlock efficiency in sourcing, leveraging artificial intelligence with PartSupply Enterprise. So before getting into the session, I would like to give a brief introduction on EDS Technologies. We are the largest, one of those largest technology solution providers in India, catering to many industry segments in engineering especially. Basically, we are in this Indian market for more than 30 years, providing business transformation experience to many customers, cutting across multiple industry segments like transportation, mobility, aerospace and defense, industrial equipment, and also many other segments like mining and all. And we are providing technologies with respect to virtual twin, geospatial analysis, and also the 3D printers for in the different industry segments. So we have been working with most of the Indian customers, more than 2,000 active customers across India, again cutting across multiple industry segments, and we provide active technical support to them in terms of providing complete business transformation experience. So we are headquartered in Bangalore, and we have 11 office locations across India: Pune, Mumbai, Ahmedabad, Noida, Gurugram, and Kolkata and Guwahati. And also we have a presence in Hyderabad, Chennai, and Coimbatore. So we are almost like 200 plus employees working in multiple locations, catering to Dassault system solutions, especially on design simulations, manufacturing, and also the social collaboration and PLM. So we are a platinum partner for Dassault Systems in India. We are engaged with Dassault Systems solutions for more than 25 years. So moving on to today's webinar on PartSupply with artificial intelligence for sourcing. So I would like to introduce our speakers, Mr. Ratish Rao. Has been there with Dassault Systems for many years. He has 19 plus years of experience providing industry consulting, product lifecycle management, and also the product information intelligence. These are the segments where he has been working consistently, and he has worked in parts of the world, especially catering to customers from North America and Asia. He has been providing the industry processes for big data, artificial intelligence, and also the virtual twin experiences of Dassault System solutions. So, Mr. Ratish Rao, welcome on board for today's webinar. And also we have another expert panelist and speaker, Mr. Uma Shankar. He has been with Dassault Systems for more than 13 years, catering to multiple industry segments, aerospace, automotive, high-tech, and life sciences. He is an expert in simulations and design solutions, and also vast knowledge on the data science. So, welcome, Mr. Uma Shankar, onto the panel today. We will be very keen to hear on today's webinar, which is majorly focusing on the parts supply. Typically, like designers and engineers, they can source and download source components from vast catalog of suppliers. They can download the parts with the 3D similarities, and also for right comparison analysis before picking up the best fit into their assemblies. And also they can make use of this for going through the engineering specifications that comes along with the sketches on these parts. They can search and source it from the catalogs. And today we have our expert speakers, Ratish Rao and Uma Shankar. They will be taking us through the session on the webinar session and the icon on this particular So over to you, Mr. Ratish Rao.
So again, good afternoon all. I'm Ratish Rao, as already introduced by Sri Kumar and Abhay. So today we are going to talk about, as the name suggests, all about artificial intelligence, right? But just to introduce Dassault System has been a leader in engineering design and also 3D based CAD modeling and simulation softwares for almost 4 decades now. And Dassault is not new to artificial intelligence either. We have a great amount of research and development happening in the space of AI, and we even have patents going way back a decade ago, where we started introducing AI into all our software platforms. So today what I'm going to talk about is how normal engineers, right, who today in their personal life are so entangled in data, and how AI tools help their personal life, right? Like everybody is aware of these days, Facebooks and LinkedIn's, and everybody talks about AI. But what if we can enable AI into their day-to-day activities in a seamless, non-intrusive manner, and help them improve their professional lives or professional work, as we call it, in terms of design and engineering, is what we're going to focus on. And then obviously the benefits will be reaped by sourcing and manufacturing, because they are going to reuse a lot of these benefits, passing on to customers as well as their sales teams. So starting with the problem statement. So one of the key problem statements we hear from all our customers, and Dassault System has 25 million plus active users of our software solutions. And the one of the number one categories I would rate it as is to be able to find relevant data in the relevant context and to be able to take action on it. So one of the challenges faced by designers is whenever, let's say as a supplier, you're working for an OEM, or let's say an OEM is working on a new design, you're faced with challenges of, okay, I have carryover parts, I also have to redesign and do detail engineering of certain new parts. But what if I can find an exact match which I already designed for a different program? What if I can find something 80% similar to what I designed before? So probably I can just do a 20% modification and move on. It can help you in a lot of different ways: time, cost, money, and quality. So as you can see in this example, you may be let's say a company, either an OEM or a supplier. So in this case, we have taken an example of an OEM, and you may be working example of a supplier, and you may be working with multiple OEMs. You may also have in-house as well as extended R&D facilities, and we all work on parts. So in this case, we assume that there are parts which are designed in computer-aided design softwares like 3D CAD. So in this notion, we also look at how digital continuity is maintained today, or maybe a lack of digital continuity. So as you can see, as the image depicts, most of the data engineers work today are spread into these multiple domains, processes, and even data sources, and not to forget data formats. So coming back to the main topic, which is design, which is most centered around parts, change, and also the related CAD drawings, related specifications, testing results, and so on. And as one of our customers recently said, they see that data is scattered into multiple different internal portals or websites, as they call it. And to be able to find the part, it's difficult, and sometimes they have to find a person who knows about the part. So it's either finding a part or finding a person who knows about the part is the challenge today they face, because they do not have a direct access to an easy to use part findability application. And as the market studies portray, as you see in the screen here, Aberdeen Group, which is a renowned agency in terms of doing this kind of market research, says that around 45% of engineers' time is spent in just searching for parts. Let's say in a day or in a week, you spend 45%. That's around 2.5 days in a productive week of experienced, sometimes well-paid, right, engineering workforce. And what if we could use that to probably double their output, or if not more? And of course, preventing that what we call proliferation of parts into downstream, right, can also help you save these costs, as you can see on the screen. Obviously, engineering and design time is a high cost item, but there is also the downstream systems like testing, manufacturing, purchasing, also maintaining inventories, right, and also spare parts, and also shipping and logistics. There are a lot of these additional costs related to parts, by just introducing a new part number. So how can we actually solve these challenges for engineering community is what we are trying to do with the power of AI. So how do we enable AI? So we have made it simple. We have said, let's use all the knowledge the system has in this space, what we have learned from our customers, and also what technology we have invested in the many years of R&D. And we have come up with a simple approach to enabling AI through a role called preferred component consumer. Basically, it is a role available to all designers and engineers, right? You have to enable it, and then it allows you to use advanced technologies to find parts or find very similar parts, also using the 3D knowledge behind the CAD model. So as you can see in this example, again, we'll get into different types of CAD systems. Here I've taken SolidWorks as an example. And I'm actually doing my design study, maybe design optimization. And I see that as particular suspension or particular spring is probably requiring some redesign, or probably I'm trying to find something cheaper, better designed in another program to reuse. So within my CAD system, I have enabled an AI-powered application which goes through all such suspension components within all my programs and all my standard components, comes back and suggests to me that probably this is something you could use, and you could simply insert it, as you can see on the bottom of the screen, and then move on. So AI has non-intrusively got into existing design process, speeding up the design process, enabling faster reuse, and end of the day, as I mentioned in the previous slide, you also get the benefit in downstream processes. So instead of designing and completing the part selection processes, which let's say account for around 70% of part selection process, there is only 30% left for sourcing and supply chain to optimize in a typical fashion these days. But what we're trying to say is, can we also move the part selection and reusability upstream so that there is much more time, much more effectivity in terms of testing cycles, or even reducing certain testing, because you would have actually made the right choices in the beginning versus trying to do it afterwards. So how do we make that happen? So in this simple example, what I showed you, we will just show in 4 steps how AI is being embedded. So we assume that engineers and designers are empowered with their, best-in-class CAD software. So it can be CATIA, it can be SolidWorks, it can be any of the XCADs like NX, Creo, or sometimes even neutral file formats like STEP, because you have an external design agency, or you may be a supplier receiving the parts from an OEM. So in all these cases, we assume that you have the 4K definition of the part, right? 4K definition attribute of the part, which we call the 3D model. And once you have that 3D model, either created or inherited from different processes, what we do is we enable collecting all the information about the part from multiple systems. So CAD is just one part of the information about the part. You'll also have additional attributes. You'll also have additional metadata, as we call it, or documentation. Once we do that, right, we obviously save that into the required spaces. So we do recommend a PLM kind of platform like 3D Experience platform, or it can be into your existing folder structures, because we know a lot of suppliers also store these assets in folders historically. So nevertheless, we support both ways, both approaches. And what we do in this particular case is, once we have the access to the CAD, we use some AI techniques to first extract more information from the CAD, which may be the shape of the part, the computed attributes, as we call it, like number of holes, number of pockets, which all uses machine learning AI to understand the CAD structure, and also what we call user-defined attributes, UDAs, right? You may have defined parametric data, you may have defined user-defined attributes. We are able to extract these from these CAD models using AI. And then what we do, we use AI to further understand similar parts. That means we not only do that for the part you saved, but you also do that for all the parts in your database or your folder structure, and keep it ready for you to be able to search. So that's why when you actually use this application in conjunction with your favorite design tool, you are able to do things which you typically do in your personal life. But in personal life, we typically use photo recognition, natural language processing, because we are all familiar with Alexas and the chat GPTs these days. But in the scientific world, as we call it, right, the design world, we deal with more accurate definitions of CAD. So we apply the same technology, but in a much more advanced way. So what we are saying is, instead of using pictures, we are now able to do the same with the CAD models designers are spending creating, so that we can enable the better search. Once we extract these, as you can see, we have a unique index, right? So we have a unique index, just like index is used by different technologies or different companies like Google or Amazon, for example. We use index to actually aggregate all this information, aggregate all the machine learning outputs into one common interface, and then embed that into an existing working environment. So here you can see I'm in CATIA V5, and I'm actually utilizing my machine learning based parts aggregation, parts attributes extraction, and then filtering through it in my CAD environment. So I may do it by shape, I may do it by attribute. So it is solving multiple challenges here. One is, can I find similar by shape? Can I find something similar based on a keyword I remember, maybe a project name, maybe a feature, maybe a description of how the part looks like, right? So we have a very advanced search running in your CAD application. You can call it an AI workbench, where you are able to interact with all your company assets, irrespective of how many systems they are residing, irrespective of what CAD format, irrespective of how the attributes are defined, either in Excel sheet, PDFs, Excel sheet, or in the PLM system, or in the CAD. We are able to extract. You are able to interrogate that and then embed that into your design cycle very quickly. Same applies for CATIA 3D Experience. Many of you are aware that CATIA 3D Experience is an advanced version of CATIA V5, which much more richer capabilities. You can see that in this case, I have an electric drive I'm trying to fix to a structure. So I have drawn a rough shape during my concept design, saying my bracket should be like this. And probably these are my design constraints where my whole position for the tooling should not be changed. So here I am requesting my AI assistant in my design tool to find me something similar. So what happens? System goes ahead and says that these are the parts in your system which are similar by shape. But in this case, I would like to see shape and size. So what I will do, I will select size as well. Now what the system is doing, system is actually helping you find brackets which fit your design criteria, which you communicated with the help of a shape. Now, it also indicates to you that somebody else has done weight reduction optimization and also marked some of these as preferred, so that you don't have to go through that study again. You have less chances of missing that part. And then you are able to ingest that, compare them, compare all attributes in its entirety, including sourcing attributes, if you would like to ingest that, so that you have 360 view of the part before you start to say, let me ingest that into my CAD model. So here I have understood the part, I ingest it, it's coming into my CAD session, and then I simply go ahead and replace my component in my design. And in few clicks, I am able to access all my company's assets, analyze all those findings which are enhanced by AI, and then I'm able to replace into my system very seamlessly upstream in the process. It can also be done in advanced CAD modeling tools like XDesign, which is a web-based CAD design software, which the system offers. So as you can see here on the right, this is another way to visualize those assets. If you are able to classify them, you are able to navigate through catalog structures which are internal or in-house in your environment. We also do provide a marketplace of existing components which are ever growing, and we have more than 100 million CAD models available to you as part of the same offer, which allows you to tap into external CAD structures if you would like. And these are very secure way of accessing, and your data doesn't flow out of your ecosystem, but you're able to access open available CAD structures on the internet. Then you're simply inserting that into your web-based CAD application in this particular example, and I'm completing my design. So it's like you have all the Legos needed somewhere within your organization, somewhere outside your organization through marketplace. You put them together and you complete your innovation design process in the CAD system. Of course, you have seen how we have done that with SolidWorks already. So in SolidWorks, you'll be able to access that using the shape. So here I selected this part. It showed me all the similar casings available for my particular model, and I'm able to simply interrogate that in my analysis and then replace that with the new structure. So as you can see here, in this case, I have replaced that blue one with the yellow one, and I'm completing my design cycle. So just to summarize what I just did in CAD structure, either in standalone mode or in powered by mode. We are able to ingest the different company assets, allow you to open it or simply drag and drop into a structure or sometimes your temp folders, and then you can complete your design. And we do offer integration to multicad, either through side-by-side browser-based integration or as a plugin, which you can see in the CAD ribbon, depending on the context. And as you can see in the beginning, we talked about three main challenges: digital continuity, because data is spread into multiple systems, and then identifying the right parts based on metadata and shape, and then how do you actually prevent the part proliferation into downstream systems by using AI-based data aggregation, AI-based real-time access to reusable data, which are cheaper, faster, and better quality. And at the end, they are integrated that into your process so that engineers do not have to install or learn or have any kind of ramp up delays in adoption. Now moving on, more of what we call a premium service. So what we covered so far is how AI helps you with simple tasks like part reuse. What we are now talking about is a much bigger stream, which we call as PartSupply premium services, which allows you to do, as you can see on the right, um, uh, perform what we call spend analysis. So once these parts are going into sourcing and manufacturing and supply chain process, you actually start spending money on them by recurring business, recurring procurement, invoicing, and so on. So we have a lot of tools and methodologies for additional roles in the organization or in the enterprise who do spend analysis, parts catalog analysis, or parts classification, depending on what type of organization structure you have. So to show you a brief, what we covered so far is what you see here, which is the EPU role, which is nothing but empowered part component consumer role. Now you can see here we have something what we say what we call as optimization role through standard component manager. Also helping you with classification is the classification intelligence analyst role, and I will talk about it into the next slides. And then last but not least, you also have component sourcing analyst, which is looking at spend analysis. So imagine the example I showed you earlier. So it can be an OEM with multiple suppliers. It can be a supplier working with multiple OEMs, etc., etc. Or even you may have remote design teams if you are a large enough organization. In many of these cases, you will have a lot of these CAD and parts spread into multiple systems. So here what we are saying is, instead of just aggregating and reusing, we are also promoting cleaning up of parts. That means, why should you have 10 variants of a specific bracket? Why can't you have 3, right? How do you start this conversation? How do you analyze the data? And how do you agree on and improve the process both for design and sourcing? So this is where standardization of components comes into play. So let's talk about the quick steps, what we did earlier, and how standardization is brought in. Earlier, we talked about how different data sources are aggregated, how you are doing the let's say unique index development by using geometrical features, additional attributes, and so on. Once we have this unique index as an additional role, you are also able to analyze using AI at a massive scale. So here you can see all the parts in your organization as an example, and assume that your organization goal is reduce 50% part numbers, right? Or reduce the new part creation rates so that you can promote more reuse. So if you have that kind of KPI or key performance indicator within your organization, this application can probably help you quickly analyze all your past assets and then quickly create classifications which are meaningful, more relevant. And many of our customers tell us that they can't do part classification studies or cleanup more than once a year because it's a very tedious process. Here is a real-time way of classifying your parts, and then also normalizing different data which may be missing or may be irregular due to acquisitions, due to change of CAD tools, PLM tools, etc., etc. So in this example, what I'm going to show you is I have aggregated all this data, but due to various reasons, right, I have 4 different attributes for mass. Sometimes it's called mass, sometimes it's called mass config, model, etc. So with a simple drag and drop interface, as you can see, the administrator or sometimes even the core engineer can say that mass in my organization means any of these 3 attributes. Now magically my system has understood, and you're not changing your PLM system, you're not changing your CAD system, you're not changing your way of working. in my unique index, I'm able to tell my system that these are all mass attributes. So you can imagine that we are not only aggregating data, we are enhancing the search, we are also enhancing the data quality in this case, so that search becomes more powerful, and you're not making issues or making recurring issues, or making a wrong choice. So what we just did, we moved from chaotic environment of managing data and sources to a very organized way of classifying parts and also setting preferred parts. That means you may have multiple parts based on cost, based on quality, based on sometimes sustainability. You may decide to have certain parts as standard parts. Rest may be an alternate part, or maybe an obsolete, or maybe marked as do not use. So how do we do that process? So in this case, beyond classification, we are now trying to understand within the classifications using this machine learning workbench, MLOps workbench. As you can see here, it is analyzing all the parts. This is a real-time view, not a fast-forwarded video. It looks at all the parts. It asks you certain criteria, so you don't have to learn any coding language. Everything is no-code, low-code kind of platform. System has identified these are different parts, and you can actually quickly tell the system that these are belonging to a particular classification. You can mark them as preferred by using this green icon, and you can mark them as do not use or alternate by using these other icons. This way you are able to quickly capture additional knowledge, also derive a standard part behavior by discussing with sourcing teams, engineering teams, as well as part classification teams, and easily communicate back to engineering. We call it advertising preferred parts to end users by making it non-intrusive but having real-time validated data to reuse. So you can also enhance this by integrating additional sources of data like ERP, purchase orders, and so on, which may get into an additional stream of analysis called spend analysis. So what we did in the beginning was aggregate those data, allow you to find similar based on similar parts. Now we are using unsupervised learning for system to come back and say, where are you spending more time? Where are you spending more money? What are the parts where you're overpaying? Because some suppliers are giving you at a lesser price for certain types of features, certain types of design templates, shapes, or sometimes tooling. So what we showed you in terms of design also applies to tooling design. So if you have tooling designs in CAD or in different attribute formats, this can also help you identify and reuse tooling structures, or even help you with approximate costing estimates, like a should be costing for some of your parts and tooling structures. So here is an example of what we call spend analysis dashboard, completely out of the box in this case, completely no-code, low-code platform to be able to change views, build your KPIs, etc. Where system has taken all the data we talked about so far, integrated spend analysis, basically history of all your purchase orders, invoices, and then looking at categories, looking at plans, looking at buyers, looking at suppliers, vendors, geography, an unlimited number of parameters in a self-service manner to do analysis. So here you can see that on a specific time period, I'm trying to understand performance of brackets within a specific plant. And I can see that certain brackets I was overpaying in certain periods of time, and in those cases, was it because of a long distance logistics shipping, etc., etc. So along with the power of AI for shapes, we are now using AI for analyzing spend patterns and finding those cost outliers, so you can take actions on them, either by finding a similar supplier or with a cheaper price, or use it for simply negotiating the price with the existing supplier. So these are some use cases out of those endless list of items or use cases we can do with the power of AI for design engineering and also benefiting sourcing. So just to summarize, now we have done this analysis on spend, which can again be embedded back into the CAD or the design reuse cycle. So it's a never-ending, iffy loop, as we call it. So you create, you produce, you use, and then you learn from it, right? Which is where you start to optimize, feed it back into the reuse cycle, making it more productive. So these are different steps we propose as Dassault System and EDS together for all our engineering and design base to be able to use AI into their day-to-day decision cycles and design cycles. And with that, I would like to introduce my colleague Uma Shankar to take you through some of this portfolio and some of the commercial topics.
Okay, thank you, Ratish. So I think what Ratish highlighted was how do you leverage your CAD systems, which is powered with AI, in order to find a reusable parts, which kind of gives us immense value in terms of accelerating time to market, and also ensuring that we start reusing to minimize the quality issues, and also to enhance the reusability across the entire design of your parts as well as the tools. This, since we're talking about tools, it also helps you to free up your working capital, reusing some of the resources that's available for us to minimize the cost. So these are high-level values that we would like to highlight as part of enabling the CAD application with the AI capabilities. So in terms of the key takeaways, Ratish highlighted some of the challenges. I want to re-emphasize the challenge, especially from enabling the CAD tool with the AI ML. Typically, AI ML tools are extensively time-consuming process in building these applications, but what we have is a kind of an off-the-shelf tool which can be powering any of your CAD applications and helping you to identify similar parts, and also to take this power of downstream process in terms of sourcing and so on. Now, we are kind of also looking at various benefits in terms of accelerating your overall design process, and as well as with the right quality that you could go to market. Now, what we have come up is, so we have an offer which is in place, which is up to the end of the year. Now, what we have done is we are trying to look at enabling your CATIA license with the AI feature. And what we are trying to do here is we would be empowering the AI on top of your regular CATIA license. And we would like to build an enterprise knowledge graph from a CAD and engineering perspective. Now, subsequently, we would work with your team in leveraging this process to downstream to sourcing and procurement. So if you would like to know more about the offer, we would request you to get in touch with the EDS team to understand more on this, and we'll be happy to help you.
Yeah, so I think we're at the end of the session. I would like to thank you, Ratish and Shankar, for delivering a very insightful session today. I'm sure our attendees and our customers would have benefited the most. As Shankar mentioned, I have highlighted our contact details. You can reach out to us for any offer-related queries or any queries related to PartSupply Enterprise as such. We'll be happy to address your queries, and we can take it forward from there. So thank you once again, everyone, for joining today at the session. Thank you, Ratish. Thank you, Shankar. See you at the next session.